Okay, so 8.8 is about vectors. Uh, so a vector is a directed line segment with an initial point and a terminal point. Vectors are identified by magnitude, which is the length, right? Or the length, and direction. So a vector must have magnitude and direction, and it's represented by an arrowhead. So the tip of the arrow is pointing towards the terminal point, and to find that position vector, you're going to have it's starting at 0, 0, going to the terminal point, okay, AB. So basically, this is the origin, 0, 0. This right here will be my A comma B. So there's my vector. The vectors are pretty useful in physics and engineering. They can represent forces. So if you have an object and you have multiple forces acting on it, each force would be represented by a vector. So the magnitude would be the amount of force. Like for example, if you had, say you had a block going down a hill. So one force would be the gravity on the block, the opposing force pushing against the block, the friction while going down opposite to the block, opposite to the incline, and then of course the incline itself going down the hill. So all those forces would be represented by many vectors. So if you're going to take physics, you'll be using these vectors a lot. 8.8, we're going to focus on the general vector, just finding how to find the length, how to find the direction, doing some operation with vectors, and just understanding what they are. Okay. So let me see. So the first thing that the homework's going to have you do, and the first thing you need to know, is find the position vector given given 2 points, I guess. Given P, 2, 3, and Q, 6, 4. So in order to find the position vector, we'll call it V. In the book, they're going to have a bold number, a bold letter. I'm going to use a little hat. That means a vector. So V is a vector. In order to find it, in order to find the point, you're going to take the initial point minus the final point. So all you got to do is subtract the first component with the first one, kind of like x2 minus x1 and y2 minus y1. So same thing. So you're going to take the final point minus the initial, final point minus the initial. So this right here will be your position vector. So this is centered at the origin, going out 4 and 1. Okay. The other way they might write this, in the homework, they're going to expect you to know both, is they could use the ij component. So this is I and j. So vector v would be 6i minus 2i plus 4j minus 3j, which would be 4i plus 1j. Or just j. So I and j would be the two-dimensional components. If you do 3D vectors, you're going to have a k component. Okay. So they're going to expect you to understand both. These little triangle brackets and this little hat implies this is a vector, not a point. It looks like this. Or you can write it this way. Same thing. These are both the same.
It's 2 minus 6 squared.
It's always the final point minus the initial point. It's always going to be that way. So they should give you a starting point and an ending point. So going from P to Q. If we do it the other way, then the vector would be facing, would be going from here to here. So the arrowhead would be opposite. Anyway, so that's what a vector is. Okay, it's just basically an arrow has length going in some direction. Direction is important because you want to know eventually, if you're going to physics or engineering, you want to know which direction the force is going. And these vectors can also be used for acceleration, velocity. So you can know, okay, well, which direction is that car going or that missile or whatever. Okay. But this first example is pretty straightforward, right? Well, you know what? We should graph it just so you can see. The vector v for 1 would be 1, 2, 3, 4, 1. So going from here to here. That's my my vector. So this is v. So once you have the position vector, you can kind of see how this right here can form a triangle, right? So in the next example, we're going to find out how to find magnitude, which is basically just a hypotenuse, right? We find the I distance and J distance. Hypotenuse of those components would be the length of the vector, which we call magnitude. Does that make sense? I'm going to do that next. Excuse me. It was so hard to get up this morning. So nice and warm. You guys cool on this page? Okay. All right. So I'm gonna extend the homework. So I still have a lot going on Fridays. I'm sorry about that. So I'm gonna give you Friday off to do your homework. Monday we'll review for exam 3. I think also Wednesday, and then we'll see. We'll go from there. So next week we'll finish 8.8, review for exam. Following Monday, exam 3. Okay, November 7th. November 7th. Magnitude and direction. Okay. So given a general vector v equal to a comma b, or if you prefer, ai plus bj, that these are the same thing, exact same thing. So again, the homework's going to give you both. So don't let that mess with you. The symbol double absolute value, I'm going to use that for magnitude because I can't write in bold. The homework uses bold bars for magnitude. Usually handwritten, we do 2 bars. So magnitude is just the a component squared plus b component squared. This is magnitude. Or length. Okay? All right. Theta is equal to tangent inverse of b over a. This is the direction of vector v. Let me go ahead and give you the other formulas now. Let's get it over with. No, it's oh, wait. Note. Two vectors are considered equal if they have the same magnitude and direction. Okay. Let me write it better. Direction. So there's a homework question they might ask you, are these two equal? Just find the magnitude and find the direction. If they're the same, cool. You're fine. Okay. So we'll skip that. Let's just practice on how to find magnitude. So example 2, find the magnitude and direction of a vector. With an initial point P, -8, 1, and terminal point Q, -2, -5. All right. So first thing you need is find the position vector. So V is equal to the terminal point minus the initial. So -8 minus a -2, and -5 minus a +1. There you go. Which will be -2, -8 plus 2. -5 minus 1, that is a -6. Let me double check everything. Positive. No? No. Where did I mess up here? Oh, I got it backwards. Terminal is -2, initial is 8, the -8. I knew something was off. Okay. So there's the position vector. Find the magnitude and the direction. Okay, so magnitude of V is the square root of 6 squared plus -6 squared, which is 72, right? 36 plus 36. Reduce that. This is 2 times 36. It's like 8 point something. I don't know. Some decimal. That's the length of the vector V. All right. Then find your angle, your direction. Theta will be tangent inverse of B over A, so -6/6, which is tan inverse of -1. Which is -45 degrees, right? It's down here. Yeah. Okay. So there's my direction. Okay. If you think about it, you could just plot the point, but now that we know the direction, you know that it's down here, right? So we have some vector going this way, -45. This is the point, 6, -6. So there's my angle and there's my magnitude. They didn't ask they didn't ask for us to graph it. I just want you to see that -45 means it's over here. But you could have just put 6 tick marks, right, and graphed it. Since it's a position vector, it starts in the center. Any questions on using the formula to find magnitude or the direction? Wait a sec.
Okay, the magnitude is, do you want the answer in decimal or?
A thing like this is fine. This is good. I prefer exact answers. The homework asks for rounding, then use the rounding. Okay. You guys cool on this page? All right then, let's do another one. Okay. Adding and subtracting vectors. Now the actual math behind it, the arithmetic is super easy, but the part I want you to see is the visual. So let's do the arithmetic first. So given that vector u, is 3, -2, and v is -1, 4. Part A, just find the addition. Find u plus v. So all you have to do is add the u components and the v components. So the i's together and then the j's together. So 3 plus -1, comma, -2 plus 4. So this will be -2, 2, right? Now what I want you to see, if I were to plot u and v separately, and I'll show you a picture too in the book. Three, -2, that's 1, 2, 3. Let's see. 3 plus that one is, yeah, positive. This plus that. Yeah, thanks. Okay. right here. This is U. V -1, 4, right? That's up here. Yeah. Weird. Okay. I can't draw very well, but I want you to see this. So there's a rule or idea called the parallelogram rule. So you add these vectors geometrically, and then you connect them and draw a hypotenuse. When you do that, you'll have the resulting vector on a graph. So let me try to show you. That means, so what you do is you connect the tip of the U to the tail of the V, and then draw a hypotenuse, okay? So here is my 2, 3. Here's my U, right? The V from here is gonna go up to here. 1, and then up 4. So this right here. So basically, picture that I'm grabbing the V and putting it on the tip of the U. That's what we're doing, okay? So the tip of the first one connects to the tail of the second one. That's what we did right here. This is U, this is V. So then you connect this part, and that is the result, U plus V. Does that make sense? At 2, 2. See that? That's what we found. So let me give you the pretty picture, because my drawings are garbage. Okay. Where is it? There it is. Oh man. So it's on the recording, but you can't see it. All right. Here we go. So this is the idea. You have a U, and then you have a V. You connect them like this, tail to tip, and then you draw a hypotenuse. That's U plus V. Does that make sense? If you have a minus, the direction flips the opposite direction. Now notice how U is still the same. They just put it on top. So the tip of the U connects to the V, which is going downward. So now the result is this one. So this would be U minus V. So this is called the parallelogram rule for finding it visually. So they have these ideas of how to find them visually, but the arithmetic is super easy, right? We just add numbers, you find it, right? But I want you to be able to see how it works, okay? Does that make sense? Any questions on that idea? Okay. Anyway, so all that to say that it's going to be 2-2. My drawing's garbage, but oh well. Barely passed art class. So. Made a cookie jar that cookies didn't fit into. It's too small. I didn't realize that the radius would shrink when you put it in the oven. Fail, major fail. Okay, u minus v. It's going to be, this time let's use the ij components just so you can see it. 3i minus -1i plus -2j minus 4j. So this will be 3 plus 1, so 4i minus 6j, or this. Same thing. Now, if you were to connect them, right, you would use the opposite version of v. Connect this to the tip of u and then draw your connection. Or just find the points 4, -6. Okay. If they don't give you points, then you'll have to use that geometry idea. Okay. That's the only time you have to do it, is if they give you a more of a conceptual question. Any question on number 3? Oh, sorry. All right. Let's move on to something else then. Scalar multiplication. So you can also scale your vectors. You can double them, triple them, cut them in half, reflect them, all that good stuff. You guys cool on this page? Scalar multiplication. Try to shorten their notes as much as I can. So given a vector v equal to a comma b and a real number k, the following will be true. So k times your vector would be equal to each component times k. All right. Side note here. When scaling a vector by k, only the magnitude changes. Unless k is negative, then the direction reverses. So if you multiply by 2k, or sorry, times 2, vector doubles in size. Do -2, it doubles in size but goes the opposite direction. That makes sense. Just flip it over. Okay. So we'll just do one of these because it's pretty straightforward, I think. Given v equal to 3, 1, find the following, 3v. We'll just multiply everything by 3. So this will be 3 times 3, 3 times 1. 9, 1. You cut b in half, well, you scale it by half, multiply everything by half. It'd be a 3. So 1/2 times 3, 1/2 times 1. The scalar makes sense. There's not much else to say. Is that okay? You just scale it. You can also add vectors while you scale them. So given a u equal to, this time I'm going to use the other notation, 3i minus 2j. I'm using it for no reason. -I plus 4j. Find 3u plus 2v. Okay, so let's do it. 3u plus 2v means 3 times 3i plus 3i minus 2j. Plus 2 times -I plus 4j. Okay. So just multiply it out and add the I components and your j components. That's it. That'll be 9i minus 6j plus -2i plus 8j. All right, 9 minus the 2. -6 plus 8. There we go. Any question on number 5? And you see how this is the same as this, right? Same deal. The notes in the book, they repeat all of what we just said and just use ij. So like, I don't think we need to do that. It's the same thing. Okay. Save some time. Let's not do that. So I'm just gonna switch back and forth whenever at random. You guys cool on 4 and 5? Okay. Right. Unit vector. So basically, a unit vector is a formula that shrinks down your large vector into a vector of size 1. So you can do easier calculations, or maybe you have a formula or something, or all you care about is direction. So you take this giant vector and change it to a unit. Okay. And all you got to do is divide by your magnitude. So if V is a non-zero vector, in the direction, let me check something real quick. Oops. Yeah, that's what it says. In the direction of V, that just sounded weird. I had to double check. Oh, I see. That's why. I missed a sentence. Say something sounds really strange here. I'm sorry. If V is a non-zero vector, then V divided by its magnitude is a unit vector. So we'll call unit vector U. So that would be V divided by its magnitude. Where U is a unit vector of V, in this case. So first example for this idea is given a unit, yeah, just find the unit vector, that's it. Find the unit vector for V equal to negative 5, 12. So the unit vector U is equal to V divided by its magnitude. So find the magnitude first. So magnitude of V is equal to the square root of negative 5 squared plus 12 squared, which is 25 plus 144. 169, right? Yeah, so it's gonna be 13. So just divide the original by 13 and you're good. So the unit vector U will be this guy divided by 13. And that's it. That makes sense? Is that okay? All right. I don't think we need to do more than one. So just take the v and divide by magnitude. That's it. We use some important formulas. So a lot of the time you don't have the original vector. Like if you had a real life problem, you might have forces coming in different directions. So if you have force coming along the vertical on the side, sorry, horizontal, then you can use your x components to find the x part. So given, let me give you the formulas first. A position vector v, I'm gonna go ahead and use x comma y, and a direction angle theta. So you may not be given this, but you may have a force going along the horizontal, which will let you find this part. You can combine it together. All right, so cosine theta is technically equal to the x value divided by the magnitude of the vector, which means that x is equal to the magnitude times cosine. And same for sine, just the y component. So y would be equal to the magnitude times your sine, right there. So you can find these parts separately and then put it together. So v is equal to xi plus yj, which is the same as the magnitude times cosine theta I plus sine theta j. And of course, if you were to square those and find the magnitude, you would get sine squared plus cosine squared, right? Leaving you with just this part. So you can always break down or build up forces or vectors looking at an x component or y component. So depending what you need or what you have, you can figure out the rest or just work with one part depending. Right? Like if you're pushing an object straight down the road, you most likely don't care about the y component because it's a horizontal push, right? Or if something's falling straight down, there would be no y component, no x component, because it's just vertical. So those are the ideas here. So you can always break them down. Maybe just use this piece or whatever, depending on what you find. Okay. Let's do one question here. Let's see how much time we got. We might have some time. You guys okay on this page? Example 7. Find vector v given the length of 7 and at an angle of 135 degrees So the vector has a length of 7 units. I don't know. They didn't say if it's centimeters or not, inches or feet. It says 135 above or from the horizontal. So just starting from 0, sweep into 135. We're in quadrant 2, right? So find vector v given only this information. Well, I can find the x component using the magnitude times cosine theta, right? Magnitude is 7. The angle is 135. Similarly, you can do the y variable times sine theta. So just plug it in. You'll get 7 sine 135. And then just find your angle. That's going to be negative for the x, positive for the y. 7 times negative root 2 over 2. Positive for this one. So our answer will be this. So the vector v would be 7 root 2 over 2i negative plus 7 root 2 over 2j. That makes sense? You got 20 minutes, right? The dot product is basically like a, you guys cool on 7, right? Okay, moving on. So let me know if 7's okay. So the dot product is just like a special multiplication for vectors. So the only difference is it's not like normal multiplication. It's like component by component. Kind of like how when you add vectors, you add the i's and the j's, right? So when you multiply, you're going to do the I times I, j times j. And that's it. So the dot product, I know it's a lot of stuff, but this section is super long. The dot product of 2, yeah, I think it should have been like 2 sections, but whatever. I didn't write this book. V is equal to a comma b, and u is equal to c comma d. Is written this way. So v dot u, let's call it dot product, is equal to a times the c, so the I components, plus b times the d, the j components. So when you do a dot product, you no longer have a vector. You get an actual scalar, some whole number, or some real number, sorry. That's all it is. Find the dot product for v equal to 5 comma 12, u equal to negative 3 comma 4. Okay. So v dot u is equal to 5 times -3 plus 4 times 12. 4 times 12. And that's it. So -15 plus, what is that? 48? Right? So u times v, you take the I components time plus the j components. And we get a number. 33, right? Does that make sense? Is it straightforward, right? Now, if you do a dot product and you get a oh, I forgot to mention. I'm gonna add an extra formula here. Now I'll have to put it somewhere else. If you do a dot product and you get a 0, then that means that the two vectors are orthogonal to each other. So like 90 degrees perpendicular. It's the other word, right? Perpendicular or orthogonal, same thing. So if you do a dot product, you get a 0. Those two vectors are separated by 90 degrees. That makes sense? If your dot product of two vectors is equal to 0, then those two vectors are orthogonal or perpendicular, which means separated by 90 degrees. That's just another neat fact, I guess. But let me write something here before I forget. We have to write this after the dot product. The angle between two vectors, u and v, is equal to this. So cosine theta is equal to v dot u divided by the magnitudes multiplied together. Yeah. So if this is 0, you can see, right? If you try to solve for theta, you're going to get a 90. Just to save you some time, cosine inverse of this dot product is equal to the angle theta. So this is magnitude v, magnitude u. I wrote that weird. I'm sorry. Can you see that? Okay. Okay. We'll do one last example and we'll call it a day. You guys okay on this page? Example 9. Find the angle between u, I think it's v and u or u and v. This doesn't matter. U and v. So u is equal to -3 comma 4. V is equal to 5 comma 12. As we wrote earlier, the formula is going to be cosine inverse of U dot V divided by the magnitude of U times the magnitude of V. So I'm going to need those magnitudes first, right? The magnitude of U would be the square root of -3 squared plus 4 squared. So that will be 9 plus 16, that's 25, right? Yeah. So that is the magnitude magnitude of U. All right. Magnitude of V will be 5 squared plus 12 squared, which is 13. Yeah. We did that earlier. All right. So that means that theta will equal cosine inverse of 5 times 13 on the bottom. The dot product will be -3 times 5 plus 4 times 12. So that'll be -15 plus, what is that? 4 times 12, 48, right? 5 times 13, that's what, 65? Or something. Uh, 33 over 65. So the calculator would give us 59.5 degrees. So they ask for angles between vectors, use this formula here. But in order to do so, you need the magnitudes and the dot product. Okay. If you notice the dot product is 0, then just stop and say, well, they're at 90 degrees. You're good. All right, we'll stop here. You guys have any questions? I'll stick around for a bit. If not, I'll see you on Monday. Next week we'll start reviewing.